everyone, my name is Helen and I'm a graduate student at UC Los Angeles, and I work with Matt Malkin. And today I'm going to present some of our results from observations with Mossfire that we took last August on Redshift 1 star-forming galaxies and NEPD. Okay, so first I'll give a brief overview of our observations. So our goal was to make measurements of H-alpha and N2 lines, and we did this by observing in the J and Y bands. And we prioritized strong emission-line galaxies that had previous data from Deimos or other spectroscopic observations, and Akari sources at redshifts about 0.7 to 1.1, and also we had one mask with the Y band where we observed lower redshift galaxies of 0.5 to 0.8. And out of the 5 masks that we observed, we found 63 successful spectroscopic detections. And here we can see 3 examples of the quality of the spectra where these have all been flux calibrated, and you can see the H-alpha and N2 lines, and in this case we can see the sulfur-2 doublet. Okay, so one of the first things we investigated was the comparison between spectroscopic and photometric redshifts. And in general, the redshifts less than 1 agree well with Nagisa's photometric redshifts. However, we can see that when we plot the residuals versus the photometric redshift, that there is a systematic offset where the photometric redshift is overestimating the redshift. And that may be due to poor data in the J and H bands. In addition, we used our spectroscopic redshifts as inputs into Segal. And so, here's an example of one of the fits where we had a lot of photometric data. So we used data from the UV to mid-infrared, but we'd also like to expand this out to the available radio data. And we assumed a delayed star formation history with an exponential burst, a Salpeter IMF, and solar metallicity. And some of the key parameters that we allowed to vary was the amount of color excess of the young stellar population, the mass fraction of P-H tests, as well as the HN fraction. Okay, so we used the output stellar mass from Segal and measured velocity dispersions for galaxies with Mossfire and also our previous Deimos detections. And this is just a preliminary result, but if we do a fit to the log of the data, we get a relationship that says that the velocity dispersion is proportional to the stellar mass to the 0.2 power. And this is less steep than a relationship that was found by Zahid et al. For quiescent SDSS galaxies, but this is something that we are continuing to investigate.
So sigma is from which line mostly?
So the sigma for the Mossfire detections is mostly from H-alpha, but also from N2. Okay. And then for Deimos, sigma can be from H-beta, O3, H-alpha, N2. And also the O2 doublet. Okay, and then next we classified our sources with the BPT diagram. And then we did both versions with N2 and S2. And we found that most of our galaxies with Deimos are star-forming, with 84% being star-forming. 3 of the galaxies that we had targeted previously with Deimos were also detected with Mossfire, which we can see with these red points here. And all of those are composite galaxies. And in addition, we plotted data from previous studies, so from Takagi and the WADA catalog in 2009 as the magenta points, and also the Shim et al. Akari NEPY data as the black points. So we can see that with our data, we actually have a higher percentage of star-forming galaxies compared to the other samples, but this might be due to the fact that those samples were targeting, in general, brighter objects at lower redshift. Okay, and finally with Seagal, we used the output specific star formation rate by combining the SFR with the stellar mass and plotted this against the the rest frame equivalent width of H alpha. And in general, we don't find a significant correlation between the two, but if we look at the higher star-forming galaxies, we can see that so here I've just plotted the one-to-one correlation, and we can see that there are some galaxies in this upper envelope here that follow this trend. And then we also plotted the reddened version of the H alpha luminosity from Seagal and from our own observations in both our data sets, and we see that they are actually within reasonable agreement. All right, thank you.